All right, welcome to another podcast episode. Today I will talk about a paper I wrote during my PhD. It's called Scaffolding Natural Selection. Unfortunately, it's not open access, so we'll have to make do by reading the preprint version, which is pretty close. And yeah, I wrote this as a follow-up to my Evolution of Multicellularity Cheating Done Right paper. Where Paul Rainey, a biologist, in his more recent work, has proposed this very interesting hypothesis for how Darwinian properties might be um, exogenously provided and then later endogenized, giving a kind of ecological scaffold for Darwinian properties to be induced on the level of multicellular organisms, which could then lead natural selection to act on that level. And perhaps that could also help us to explain the evolution of life itself, with natural selection becoming a force in the universe. Um, so, again, I'll read this paper out and I'll provide some comments along the way. Scaffolding natural selection, abstract. Darwin provided us with a powerful theoretical framework to explain the evolution of living systems. Natural selection alone, however, um, has been has been seen as insufficient to explain the emergence of new levels of selection. The problem is one of circularity for evolutionary explanations. How to explain um, the origins of Darwinian properties without already invoking their presence at the level they emerge? That is, how does evolution by natural selection commence in the first place? Recent results in experimental evolution suggest a way forward. Paul Rainey and his collaborators have shown that Darwinian properties could be exogenously imposed via what they call ecological scaffolding. This could solve the black box dilemma faced by Darwinian explanations of new levels of organization. Yet, despite scaffolding recently becoming a popular term in the study of cognition, culture, and evolution, the concept has suffered from vagueness and ambiguity. This article aims to show that we can use scaffolding and turn it into a proper scientific concept able to do explanatory work within the context of the major evolutionary transitions. Doing so will allow us to once again extend the scope of the Darwinian model of evolution by natural selection. Introduction. Darwin provided us with a breathtakingly simple yet powerful tool to explain the evolution of living systems. That is the theory of evolution by natural selection. Of all the principles in biology, natural selection appears to be the closest thing biologists have to something resembling a general ordering principle in physics, subsuming a vast range of diverse phenomena under a single theoretical framework. See Okasha 2018. Externalist approaches relying on natural selection that explain organismal properties through recourse to properties external to the organism, however, have often been considered insufficient to explain how levels of selection, that is, the major transitions in evolution, such as the origins of life and evolution of multicellularity. Smith and Sasmari, 1995. By the way, I won't read out all the references because at some points in this text there's just going to be several right after another. But for those watching the video version, you can see the text in front of you, or you can download the text to find all the references. That is, how does evolution by natural selection get started in the first place? This problem has long been a major challenge for evolutionary biology. As James Griesenmer argued early on, the very reason it has been so hard to explain the major transitions has been something like a problem of circularity. Since Darwinian explanations invoking natural selection typically already assume the pre-existence of so-called Darwinian properties at a level of spatial organization, such as Lewontin's preferred trait of variation, fitness differences, and heritability, there's an inherent challenge in offering hypotheses that explain the origins of these properties without recourse to the very properties we intended to explain in the first place. This is the most obvious for the origins of life, where the emergence of Darwinian entities is typically explained through non-Darwinian means, that is, through appeal to principles of biochemistry and physics. While there's now very extensive literature, both theoretically and empirically, on such evolutionary transitions in individuality towards a new level of organization, so-called ETIs, the dominant view has simply assumed the existence of some higher level Darwinian properties, without realizing that they cannot be just taken for granted. Here's an interesting footnote. It's probably the only one I'm going to read out, but it's important for this paper. Externalist approaches should be conceived as the opposite on a spectrum to internalist approaches that explain organismal features through recourse to other properties of the organism. In practice, the difference between these two modes of explanation is admittedly often only one of emphasis. Despite significant progress having been made, interesting how all of this is green. Yeah, Overleaf LaTeX made all of this a link for some reason, which is one of the reasons I'm now using Word again. But the main reason is that almost none of the publishers accept LaTeX submissions, so you might as well just write in Word. The literature remains far from reaching consensus regarding both general theoretical debates and in its mechanistic hypotheses. The black box dilemma forced upon us by the recognition that Darwinian properties are themselves derived traits in need of Darwinian explanation has been largely unaddressed. Recent work by the biologist Paul Rainey, however, suggests a new exciting path forward that could simultaneously offer both a general theoretical framework for the major transitions and a testable empirical program that may break the circularity problem entirely by employing natural selection itself in the emergence of Darwinian properties. A new proposal: ecological scaffolding. In his recent collaborative work, Rainey has developed his idea that Darwinian properties could be exogenously rather than endogenously imposed through a process that he calls ecological scaffolding, thus allowing natural selection to commence in something like an eco-evolutionary feedback loop. Rainey et al., 2017. While a further mathematical exploration of the idea by the physicist Andrew Black involved the philosopher of biology Pierre Bourrat, there have been yet no discussions really of the idea in philosophical circles, save for a brief mention in Fight, 2019. Yet the idea of ecological scaffolding is already being applied and further developed elsewhere, such as in Dulcier et al. 2020, where it is explicated using mechanistic models in the context of egalitarian transitions, where lower level entities are alike, to explain the origins of heredity. This lack of attention among philosophers of biology is unfortunate, for two reasons. Firstly, Rainey's idea of ecological scaffolds presents a unique merger of theoretical biology, experimental work, and philosophy of biology in order to address the problem of major transitions that researchers in all three fields have long been wrestling with. Philosophers of biology may thus be interested in seeing an elegant case demonstrating how ideas from multiple disciplines can be turned into a new research program. Secondly, and perhaps more importantly, philosophers of biology are in a unique position to analyze and further explicate the notion of ecological scaffolding in order to help it flourish into a novel research program on the major transitions. This idea is intriguing because it solves the circularity dilemma faced by Darwinian explanations, relying on natural selection. In this paper, I will take the opportunity to further develop the idea here in order to make progress in our understanding of the major transitions within an evolutionary framework. Despite the fact that the term scaffolding has recently become a popular theme in the study of cognition, culture, and evolution, and even science itself, the notion has generally suffered from vagueness, imprecision, and ambiguity. If one hears the term used in different contexts or by different scientists, it is often unclear whether there is any shared understanding. After all, there is no generally agreed upon definition, even within particular disciplines. This provides ample opportunity for philosophers of science to step in, as two of the most beneficial roles philosophers of science can play in the sciences are those of conceptual clarification and theoretical incubation. This paper aims to draw on the work of Rainey to show that the notion of scaffolding can be successfully developed from a mere metaphor that is used in a vague sense describing environmental support into a proper scientific concept able to do explanatory work within the study of the major transitions. By developing a general definition of scaffolding, I aim to help Rainey's project to incubate a new set of ideas in the study of evolution. Doing so will allow us to address old philosophical questions on the scope and explanatory power of natural selection open an array of research topics at the intersection of experimental biology, theoretical modeling, and the philosophy of biology. Article outline. In order to achieve these goals, the article is structured as follows. In section 2, I briefly illustrate the circularity problem that threatens the status and generality of natural selection as the unifying principle of the biological sciences. In section 3, I analyze Rainey's proposal of ecological scaffolding as a solution to this problem and a potential explanation for the major transitions. In section 4, I explicate and improve the concept and its role in evolutionary thinking by linking it more closely to recent ideas in the philosophy of biology, such as Amir Kasha's work on the strategy of endogenization, Peter Godfrey Smith's idea of scaffolded reproducers, and the scaffolding literature more generally. Finally, I conclude the discussion in section 5 and suggest further avenues for research. Two, a circularity problem for the generality of natural selection. Since Darwin's The Origin of Species by Means of Natural Selection, his concept of natural selection has fundamentally changed biology and understanding of the world. Previously, no one had been able to provide a satisfying explanation of the design and apparent fine-tunedness of organisms to their environment. His perhaps most often quoted formulation of natural selection is offered in the latter part of The Origin. These laws, taken in the largest sense, here it's a block quote, being growth with reproduction, inheritance, which is almost implied by reproduction, variability from the indirect and direct action of the external conditions of life, and from use and disuse, a ratio of increase so high as to lead to a struggle for life, and as a consequence to natural selection, entailing divergence of character and the extinction of less improved forms. Charles Darwin, 1859. As several authors have noted, Darwin emphasizes two special features of natural selection. The first one being the almost law-like form of natural selection. If the conditions for natural selection are satisfied, natural selection operates. This, importantly, does not require that evolutionary change or adaptation occurs, as other evolutionary factors such as drift may undermine the effect of natural selection. The second special feature of natural selection that Darwin emphasizes is the abstractness of the process. This feature allows for selection on different levels of organization, just the obvious case being organisms, leading to the fairly heated group selection debate on the proper level of selection. As I indicated in the introduction, the principles of natural selection are often simply stated as the satisfaction of three conditions. 1. Variation. 2. Heritability. And 3. Differential reproductive success. In his paper, The Units of Selection, Lewontin provided the perhaps most cited formulation of these three ingredients in the Darwinian algorithm of natural selection. Another block quote, as seen by present-day evolutionists, Darwin's scheme embodies three principles. 1. Different individuals in a population have different morphologies, physiologies, and behaviors. Phenotypic variation. 2. Different phenotypes have different rates of survival and reproduction in different environments. Differential fitness. 3. There's a correlation between parents and offspring in the contribution of each to future generations. Fitness is heritable. These three principles embody the principle of evolution by natural selection. While they hold, a population will undergo evolutionary change. Quote end. Naturally, it has been recognized that these three criteria can be satisfied at different levels of biological hierarchy, though there have been many disputes regarding the status of levels other than the organism, such as the group or the gene. Far from being solely tied to biology, many thinkers have also since used the tools of evolutionary biology to explain cultural evolution, giving these conditions cultural interpretations. As Godfrey Smith emphasizes, the very, quote, idea of an extension of Darwinism beyond its original domain is almost as old as Darwinism itself. Quote end. But explanations employing natural selection will inevitably be faced with a problem of circularity that the Darwinian project has to address. Regardless of how the specific conditions for natural selection are explicated, these Darwinian explanations will still be insufficient to explain how these conditions themselves came into existence, especially in the case of the origin of life. The problem here is not that the conditions for natural selection we have specified have been stated too strictly and would require a more relaxed form, though such an approach might be useful to provide a better understanding of natural selection itself and the very first selection processes in the hierarchy of life. There's a deeper conceptual problem here that cannot be overcome by such an analysis, since it lacks a mechanistic explanation for how this process comes to operate. In a previous paper, I've summarized the problem Rainey tries to address as follows. Quote, models already assuming a level in the hierarchy of life, the evolution of which we want to explain, must conceptually prove insufficient for the purposes of explaining the evolution and persistence of new Darwinian individuals on a higher level. After all, one needs to explain the emergence of a mechanism of group reproduction, without such a mechanism already being present. Veit 2019a, page 4 to 5. Similar points have been made by Griesimer, who argues and urges us into mechanistic detail in order to address the circularity problem. Hierarchical organization cannot be simply taken for granted as if it was just exogenously given, and yet this fact is typically already assumed in evolutionary models. The levels of selection question must address the origins of biological organization. So far, there have been numerous ingenious attempts to address the evolution of reproduction at a new level, often within a kin selection framework. But this work has largely focused on the internal side of things, with Darwinian properties emerging as a result of interaction among parts, with relatively little attention given to the ecological context as one might expect from the externalist model of natural selection. I emphasize the term externalist as important here, more so than any other field, because evolutionary biology is dominated by an externalist mode of explanation in which features of a system, that is the organism, are explained in terms of properties of features external to it, that is the adaptive fit to the environment. As the evolutionary biologist Alan Stoltzfus elegantly puts it, quote, the suspicion of internal causes in the dominant neo-Darwinian culture ran so deep that every internalist idea, no matter how reasonable, was treated as an appeal to vitalism. And yet, to explain the evolution of Darwinian properties in terms of external selective pressures has been precisely the source of the circularity problem, because it apparently presupposes the existence of the level of organization we are supposed to explain in the first place. It is thus unsurprising that some, such as the cell biologists Stuart Newman, have emphasized the role of physical laws and constraints over the generality of natural selection and adaptive explanations in thinking about evolutionary transition to multicellularity, despite the resistance to non-Darwinian explanations. This is certainly one way to circumvent the circularity problem. Employ a non-Darwinian explanation of the emergence of Darwinian properties. My goal is not to claim that this approach does not work. In fact, there may very well have been too little attention given to the possibility that multicellularity itself is not an adaptation, and I would be pleased to see a more pluralist approach to modeling the origins of multicellularity. I cited a bunch of papers where I've argued for pluralism in science. Rather, my goal here is to demonstrate the idea that natural selection may itself be scaffolded has the potential to once again be extended and extend the scope of natural selection as a general ordering principle in biology by providing a non-circular Darwinian explanation of the emergence of Darwinian properties. Here, I explore Rainey's notion of ecological scaffolding as an externalist and mechanistic solution to recover a Darwinian approach to the circularity problem. In contrast, the prevailing paradigm has been to explain the emergence of these properties in virtue of the interaction of lower-level particles. Reproduction, for instance, is often considered as a simple byproduct of natural selection acting on particles at the lower level. Yet a mere assembly of single-cell organisms does not have a special group mechanism of group selection. So where does it come from? What ecological scaffolding allows is for us to fill out these gaps and provide Darwinian explanations for the origin of Darwinian properties, that is, the conditions under which natural selection acts. As Griesimer urged early on, we should recognize that reproduction is not a simple process, instead often being composed of the complex interactions between various parts. Collective level reproduction is not the same as reproduction at the level of individual cells, but something that requires an explanation of its own, a fact that is unfortunately often overlooked or idealized away. But to explain the evolution of multicellularity, is it Black et al. 2020 note intimately linked to the to explaining the emergence of life cycles, development, and the soma-germline distinction. It is nowadays not uncommon for people to think that natural selection is an important force once its conditions are satisfied, but then to hold that these Darwinian properties could only have been arranged for something like a higher power. See Nagel, 2012. Recent work on scaffolding, however, may be able to undermine this leftover of pre-Darwinian creationist thought. From the origins of life to the evolution of multicellularity, ideas stemming from work in experimental evolution have offered a novel way to solve this omission in evolutionary biology. Though I suspect it unlikely that a scientific concept of scaffolding will turn creationist, it has the potential to at least remove this force of the argument, providing us with a simultaneously generally attestable mechanistic framework for thinking about the major transitions. Let me thus now introduce Rainey's concept of ecological scaffolding as an externalist solution to the circularity problem, one that does not rely on an internalist's explanation seeking the emergence of Darwinian properties as an interaction between parts. And now, because this paper is quite long, I'll split this video in a couple of parts, and I'll see you in the next video.